Hey class, today I'm going to be Sven, the water molecule. I can come in three forms: frozen, liquid, or vapor, such as saunas, which are great. And I am going to teach you about critical zone science, which is thinking about the zone of the earth from where the bedrock ends to the top of the trees. And in this zone, from the treetops down to the solid bedrock, there's a lot going on, from weathering of bedrock into soil, storage of water, growth of plants, growth of animals. And the whole biosphere is really dependent on this interface zone. And we're going to learn a bunch of key terms today that are relevant to this kind of zone, thinking about it in cross-section from the top of the trees down to the bedrock. Every time I mention a key term, I'm going to give you a nice Sven thumbs up. And you're going to have to want to take note of that, maybe rewind back to that so you can really understand the definition of that key term, or look it up later to see if you really understand what it means, because what we're going to have to do with all these key terms is put them together into a larger cross-sectional diagram of the critical zone. And so we're going to walk through all these things now as you follow me through this amazing New York State forest behind me here. Yeah, I'll let you guess where I am in the great state of New York. So Sven, the water molecule. Often I will start frozen way up in the sky. I will come down to the earth as a hydrometeor, which can be basically in the form of frozen or liquid. Hydrometeor is just a general term for any falling group of water molecules. So say I was a rain droplet or a snowflake, I would then fall from the sky, and the first thing I would intercept would be the forest canopy. If I'm in a forested system, or if I'm in a field, or even in a lawn, I'd still hit the vegetation canopy first. So a certain amount of that precip is going to accumulate on the vegetation, and then a certain amount is going to make it down to the forest floor. And so you can see here, this amount that made it through, we call this through fall. And you can see there's about an inch of snow here accumulated underneath these hemlocks above me, or sorry, balsam firs. Now you go over here to the opening, dig down, and you can see we have probably over 5 centimeters of snow accumulated here in this area. And so you can see that a lot of that snow that fell from the sky was caught by those trees, and the rest, as through fall, made it down to the ground. So once that water molecule makes it to the land surface, it can either accumulate over a season or over a storm event. Oh, a little through fall on my shoulder there. It can accumulate to make a seasonal snowpack, or it can melt and infiltrate into the subsurface. So infiltration, another good one there. And when that water infiltrates into the subsurface, it's then going to flow through a variety of networks, which we're going to look at in a little bit here, of where that water can go. If that water doesn't infiltrate, it then becomes what we call overland flow. So maybe the ground is still frozen below us, and then that overland flow would then move above that frozen ground and, say, into this river next to us here, directly over the land surface. Now, if you have frozen ground, or if it rains really hard and the rate of infiltration is not able to take the rate of rainfall coming down, because only a certain amount of water can make it into the soil in a given time. If you exceed that infiltration rate, then we get what we call sheet flow, which is essentially sheets of water moving across the land surface. You'll see this during really intense, like, thunderstorm events, and that'll run off directly into the river as well. Great. Then we think now back to where that water is going in the subsurface and what's happening in the subsurface there. So I'm going to take you on a little adventure here, and you're going to follow me as we go down to look at a nice cross-sectional view of the subsurface. So we obviously have trees. We have both needle leaf trees, you can see here, good key term as well, and broadleaf trees this time of year without any leaves on yet. Broadleaf tree, kind of two general catch-all terms for different physiologic types of trees that are going to really matter for things like through fall and eventual loss of that water back to the atmosphere. So it's a little snow covered, but you can see here that we have these trees moving down into tree roots. Now you can see a bit of the subsurface here, and you can see that we have some major roots still dominating a lot of that subsurface. And so the really large roots are what we call tap roots. And then we also have fine roots here, which make up a lot of the biomass actually in the subsurface. So we have tap roots, key term, and fine roots, another key term. So that water infiltrates back to where we were as a little hydrometeor. And as that water infiltrates, it can move into the subsurface. You can see nice look into an eroded subsurface here. You can see those fine roots coming down, some tap roots dominating the surface. There's a little nail there from this dock I'm at. And you can see in the subsurface here, there's a lot of pathways, particularly along those root networks, for water to make it into the subsurface. So infiltration often happens along these root networks, and this is what we call focused infiltration, and these roots are often referred to as macropores. So instead of like the fine pore spaces between all of the sediment in the soil, you also have macropores, which are along these root networks, and they allow water to infiltrate from the surface into the subsurface. And then once it's in the subsurface, it helps it to actually move down deeper into deeper material. That process of moving deeper is what we call percolation. Another thumbs up there. So percolation is the process after the water is already in the subsurface of moving down from upper layers in the soil into lower layers. And this soil can be loose, or it can be made up of a variety of fractured bedrock as well. And so all together, we call it the regolith. Another thumbs up. The regolith is a general term for all of the weathered material from the land surface down to the unweathered bedrock. And in that zone of regolith, things are considered to be in the process of converting from fresh bedrock into the soils that we see at the surface, and eventually eroding, making their way down in the river systems, and then getting pulled downstream to accumulate and maybe mix sedimentary rock later, much later in their life. Great. Okay, so back to this hydrologic cycle. Taking a few tangents, but I think you can piece it together, make a nice diagram. So we go from infiltration into percolation along macropores and just the background matrix of space in the soil. Get into the subsurface and farther deeper into the regolith, and we are then eventually going to make our way down to the groundwater table. And where the groundwater table is easy to see here, because The groundwater table is where all that soil is saturated, and it's always going to be at the edge of a water body like a stream or a river or a lake. The level of the lake or stream or river is going to be the same height as the groundwater table. So you can see from here the groundwater table is just about a meter below what we're looking at right now. And then finally, that groundwater can then flow through the subsurface into these different water bodies, or get pumped out and used for drinking water like it does in a lot of the world. And then finally, we have this process of ways that water makes it to, we have a third way that water often makes it to a stream or river from the land surface. So we talked about overland flow or sheet flow. We talked about this deeper infiltration into percolation into groundwater movement through the groundwater table. And then the third way is infiltration along these macropores, but these macropores can be so extensive in the subsurface that they can actually create a really good way for lateral flow to occur. So moving down the hill slope, this water moves along the macropores and moves directly along the macropores into the river and stream networks without ever making it into the groundwater table and into the saturated groundwater zone. Instead, it's moving through the vadose zone. Another thumbs up. So what is the vadose zone? Well, that's something I'll have you look up on your own. So you can make sure you get the spelling there right. But the gist of it is that it's everything above the saturated zone. So the groundwater table is the top of the saturated zone, and from the top of the groundwater table to the land surface is the vadose zone, which is a zone unsaturated with water. So there's still water there, but it doesn't saturate all the pore space. And then finally, we have the last step, which is where water can make its way from the land surface or a river or stream or lake back to the atmosphere. And I think you can all know the key term there, which is evaporation. But if that evaporation occurs via a plant, so say here in this bright sunlight, we have, let's see an example. There we go. I have a nice white pine over here. So this white pine, it's above freezing. So that means that it has the capacity to take any available liquid water in the subsurface, move it up its trunk, through the tree needles, and out to the atmosphere and above. And that process is called transpiration. Another key term there for you. So evaporation is generally the term for when water moves from a liquid state to a gaseous state, and transpiration is when that process happens via a plant. And finally, there's sublimation, which is where you take frozen material, such as this snow here, and instead of melting it to water and then evaporating it, it sublimates, which means it moves directly from the form of ice into water vapor. So sublimation is that next key term there. So that water can transpire via a plant. It can evaporate generally from a liquid to a gas, or it can sublimate from a frozen material into a gas and move back to the atmosphere. And so Sven, your little water molecule, found so many ways to move from the atmosphere above down, some getting trapped in the forest canopy, but some making it down as throughfall into the land surface, where it had three pathways of overland flow, infiltration into lateral flow along root networks and macropores, or infiltrate, then percolate down deeper into the groundwater table and into the eventually some surface body of water. And then once all that water is down, either in the soil or on the land surface somewhere, or a surface body of water, it can then evaporate out, it can transpire out, or it can sublimate off as a little frozen water molecule. So there's a little recap, and hope you enjoy. Have a nice little view too. Okay, see you in class, at least virtually.